A lot of fun, this inverse function stuff. So we're going to go through our final theme. And that is, now I've rewrote it in a different way. So g of x and g inverse of x are inverses. Two functions are inverses if and only if g composed of g inverse of x is equal to x. Or g inverse of g of x is equal to x. Now, this is a composition of functions. So this first one, now I'll write this in another way, and it may not get any easier. The g of the, sorry, let me try to say this. The g of the g inverse of x is equal to x. If that is a true statement, then these are inverses. Or if you apply the inverse function to the function itself, g, this should equal to x. If you can demonstrate that if one of these is true, then we do have inverse functions. Now, press pause here, and I'm going to give you a task. Which one do you think will be easier to demonstrate the g of the g inverse of x or the inverse g of g of x? That made no sense to many of you, and I understand. So during this, press pause. Maybe you want to go through composition of functions very briefly. All right, welcome back. So here, I'm going to, maybe this is still 1, and this is 2. I'm going to talk about what 1 means. 1 means that our output for our inverse function, which is this, I could pack that up and put it into the inverse, or sorry, and put it into the input x, right? To me, I really like that because a squaring undoes a square root. That seems very, very nice. Whereas, if I do it the other way, if I pack up this and plug it into there, will that work out? Both of them do. So let's just do one. So if this is not a true statement, if we can't let the output equal to x here, then they're not inverses. So I am going to try to verify. So I'm going to write verify. By the way, I know some of you guys are like, he wrote ifs with 2 f's. This is so important. So this means that if this condition is true, then I have an inverse function. If I have inverse functions, then this must be true. So if you can identify either way, we have an inverse function. So anyways, get back on track here. I'm going to verify. Now I think, to me, if I pack this up and put it into my input of g, that would make sense to me. So I'm going to verify g composed of g inverse of x is equal to x. What I will do is I will work extensively on the left-hand side here, and I'm going to hope for an identity or a statement of truth, or x is equal to x, which would be fantastic. So now g composed of g inverse of x, so I'm just going to write that in another way. G compose, or g of g inverse of x. Does this equal to x? Question mark. This is not a true statement yet. This is what I'm trying to verify. So g, now what is the output of my g inverse of x? Is equal to the square root of x plus 4. Again, this is a question, not a statement yet. So now, if I apply my function g to this input, what I get is My function g is just a set of instructions that says take your input, square it, subtract 4, right? And my input here is the square root of x plus 4. Right about now, you may recognize that squaring a square root cancel each other out. More precisely though, the inverse of a square root function is squaring. So these two operations undo each other, leaving only x plus 4 minus 4 is equal to 0. Now, this is, hopefully you're able to say, oh my god, this has to be a true statement right now. X plus 4 minus 4 just leaves me with x. So x is equal to x. This is true. So I have verified that this is true. So since this is true, g of x and g inverse of x are inverses of each other. Now, that is a lot of fun. And there is a question in your homework that will make you a better math student. It is rough and tough, but it is my favorite question. So 2F, very, very tough. If you have the time, please undertake it. Very interesting as well. If you have any questions, feel free to reach out to me. And have a good day. I think it's going to be sunny.